In an earlier video, I did an experiment where I connected a pickup directly to the output jack, bypassing all the electronics, and I did hear an improvement in the brightness. It's not a practical solution though, because you gotta have some volume pots and a tone control. So today I'm going to leave the volume pots in and I'm just going to bypass the tone control. And this is something you can do with what's called a no-load potentiometer, where you modify the pot to, when you turn it all the way up, it basically disconnects the pot, removing the tone capacitor from the circuit completely. And let's see if it improves the brightness at all. So I've still got all the electronics pulled out and mounted on this piece of cardboard, and I've clipped in with alligator clips a new pot. It's a Bourne's 500K audio taper pot, and when it's all the way up, it's at about 488K. I measured it on a multimeter. And I've got the tone capacitor hanging off it just with a clip, and this will let me pull in and out the tone capacitor. So here it is, playing through the clean channel of my Vox VT30. Just all the way up on the tone pot with the capacitor. Alright, let's pull the capacitor off just by disconnecting it with the alligator clip. So let's take a look and see how this modification is done. First step is to remove or lift up these 4 tabs. I'm going to use this sharp, straight edge screwdriver just to wedge underneath those tabs and lift them up. They're pretty tight when you first get started. You may need to use something even sharper, like maybe the sharp edges of some cutters. Just be careful not to cut them off. Alright, with those lifted up, the entire body of the pot just pulls away. Typical tone control, you don't even use this lug. Just ignore it. You're only using these two. And in this case, what this thing is turned into is just a variable resistor. It's not a voltage divider the way it is if you're using all 3 lugs. So a variable resistor, used to be known as a rheostat, is simply saying we're choosing a resistance between these 2 lugs by turning the pot. And what we can do for a no-load tone control is when you turn the pot all the way up, normally now you're at the maximum resistance of this pot, which in this case is 500K, but if we take a razor and simply cut some of the carbon material off here, when the wiper turns around to reach that point on the track, there'll be no conductor at all anymore, and the resistance will become infinite. Therefore, no signal will be able to leach out through the tone capacitor. It'll be basically as if there's no potentiometer or capacitor at all. What we want to do first is confirm where the pot actually is when you turn the shaft all the way up. And to do that, we need to bring back in the back of the pot. See, as you notice right now, nothing is stopping this from just turning. The thing that actually stops it is this tiny little dimple right here in the back of the pot. That dimple makes just a mechanical barrier from this raised section of the wiper. See, the back of the wiper has this little lip on it. And that lip just needs something to bump into. And that's the dimple. So what I'm going to do is stick the back of the pot back on here. Once I'm holding it in place, rotate the pot until it stops. Now if we take the back of the pot back off, you can see where the wiper is positioned when it's up all the way full. The wiper is all the way right here at the end of the track, which is where we'd expect it to be. So now what we can do is decide how much of this material to scrape off so that as you turn up the pot and it reaches that point, it'll remove the load from the circuit. And you know, you could think, well, do you want it to go no load at 95% or at 90% or at 85%? You decide how much you want to remove. And since we can't remove this plastic disc, as I mentioned, I'm just going to rotate it to get it out of the way to about there. I'm going to take my razor and I'm basically just going to get in here, the position I determined before, and cut the trace. Just give it a scrape. Now I'm just going to use I've sort of broken off the tip of this to make a little scraping surface. I'm just going to get in there and scrape. And that is it. Okay, last thing to do here before we reassemble the pot is to double check that we've done a good job cutting the trace. So using the multimeter, I'm just going to connect it across these two lugs like this, and we immediately see a reading of 391K. As I turn it down, you can see how it works. It's 46K. But if I turn it the other way, as we approach the end of the pot, at some point, it's 430. At some point, we'll just see it go infinite. 445. Boom. Infinite. And after that, nothing else can connect because we've cut the trace. As we go back down, there we go. So it jumps from about 450 to infinite. Okay, so the last thing to do is put the back on. Just try to line it up the way it was before. You might want to just make a mark on the side of the pot that says this is a no-load pot, so you remember it. Okay, all done.